NASA has confirmed the discovery of an Earth-like world that is in the habitable zone of its star. It is located 600 light-years away in the constellation of Lyra and has been named Kepler-22b. At first, scientists thought this could be the long-awaited twin Earth because it orbits in the habitable zone where temperatures could support life as we know it. But we now know that this planet isn't like Earth at all. It is, in fact, a gas giant almost twice the size of our home planet. So how can something so massive be considered Earth-like? And will we ever find out if there is life on planets like this? To understand why scientists described Kepler-22b as Earth-like, we need to learn about some of its features. We know from studying its light curve that the planet is around twice the size of Earth. The length of its orbit and the brightness of its star allowed astronomers to calculate that it has a mass about 10 times greater than Earth. In 2013, researchers were able to determine that it has a year that is just 290 days long, which is pretty similar to our own. This means that it orbits closer to its star than Earth does to the Sun. In addition to this, it orbits a star that is smaller and cooler than our Sun. All of these factors combined made scientists think that Kepler-22b could be a great candidate for hosting life. But our hopes were soon dashed when NASA released new data that revealed the true nature of the planet. The latest analysis of the planet has shown that it is most likely a gas giant with a radius that is 1.5 times larger than that of Earth. As far as we know, this makes it the smallest gas giant discovered to date. Unfortunately for those hoping for another Earth, this latest discovery makes it highly unlikely that it could support life. Gas giants are known to have extremely hostile conditions, and their atmospheres are not suitable for life. The pressure and temperature deep within the planet's atmosphere would destroy any spacecraft sent to study it. And what little we know about its atmosphere near the surface suggests that it has huge storms, crushing atmospheric pressure and temperatures hot enough to melt lead. Gas giants also don't tend to have solid surfaces like Earth. Instead, they have a core surrounded by a mantle of liquid metals such as iron and nickel. Then comes the atmosphere, which gets thicker and thicker until the pressure is thousands of times that of Earth's atmosphere. At some point, the atmosphere becomes a liquid, and then a deeper layer of liquid metal surrounds the core. Now, despite this, Jupiter and Saturn both have solid surfaces that you could theoretically stand on. They're located towards the bottom of their atmosphere. But on Kepler-22b, the atmosphere is so thick that it wouldn't have a clear boundary between the liquid and the gas, and any spacecraft attempting to land on it would simply sink into a slushy mass of crushed gas and rock. Now, this might sound a bit confusing. How can a planet be bigger than Earth but have less mass? To help us understand this, let's look at the structure of a typical gas giant like Jupiter. As I already mentioned, Jupiter is mostly made up of hydrogen and helium, much like the Sun and other stars. It's thought that these elements formed the majority of the planet's atmosphere and were left over after it formed from the original cloud of gas. Now, deep inside, the pressure and temperature become so extreme that the gases start to liquefy. At this stage, the atmosphere is still many hundreds of miles deep and extends all the way from the top of the planet to the boundary between the liquid and the gas. Now, the exact depth of this layer is unknown, but it's thought to be at least several hundred miles thick. The next layer of Jupiter is a liquid metallic hydrogen layer, which extends for several tens of thousands of miles. It's thought that this layer is what generates Jupiter's powerful magnetic field, which extends over 70,000 miles into space. It's this magnetic field that's responsible for trapping charged particles and giving rise to the aurora. Finally, at the center of Jupiter, there's a rocky core that's about 20 times the mass of Earth. Now, while Jupiter has a well-defined boundary between the liquid and gas phases, this may not be the case for Kepler-22b. The pressure and temperature on this planet are expected to be even higher than those on Jupiter, which could cause the atmosphere to be in a slushy state that extends for hundreds of miles. This is what makes Kepler-22b so different from Earth. Our planet is mostly made up of rock and metal, whereas Kepler-22b is mainly composed of hydrogen and helium, just like the Sun. This means that it's unlikely to have a solid surface like Earth. So now you've probably got a lot of questions about what lies beneath the surface of a planet like Kepler-22b. Unfortunately, we may never get a definitive answer. Trying to probe the interior of a gas giant would be incredibly difficult due to the harsh conditions in their atmospheres. It would be like trying to drill through the entire atmosphere of Earth in order to reach the core. Even the most advanced spacecraft would be utterly crushed by the immense pressures and temperatures found in the atmospheres of these planets. However, we can use computer models to try and estimate what's inside Kepler-22b. One such model was created by researchers at MIT, and it suggested that the planet has a large core that's around 4 times the mass of Earth. The rest of the planet is then made up of a thick layer of liquid hydrogen and helium. Another model suggests that the planet is actually an ocean planet, meaning that it's mostly made up of water. Now, this may sound strange, but it's possible that the intense heat and pressure on the planet could keep water in a liquid state, even though it's orbiting a star that's similar to our Sun. The only way we can verify these theories is by sending a spacecraft to study the planet up close. But this will be no easy feat. Even if we could build a spacecraft that could withstand the extreme conditions found on planets like this, it would take many decades to reach one of these planets. Take, for example, Voyager 1, which was launched in 1977 and is currently more than 14 billion miles from Earth. That's the furthest distance that any human-made object has ever traveled. Even if Voyager 1 was sent to Kepler-22b, it would still take over 80,000 years to get there. And unfortunately, Voyager 1 is heading in the opposite direction. For now, the only way we can learn more about planets like Kepler-22b is by using telescopes to observe them from afar. The James Webb Space Telescope is already helping us to study exoplanets in greater detail than ever before. So it's possible that we'll learn more about this mysterious gas giant in the future. But for now, we can say that it's definitely not the Earth-like world that some people were hoping for. But would you want to live on a planet like this? It doesn't seem very welcoming. And do you think we should try to explore planets like this, even if it would take many years to get there? Let me know your thoughts. And if you enjoyed this video, please leave a like and subscribe for more videos about space. Thank you very much for watching, and I'll see you next time.